Good morning, students. Welcome back to our online class. So, in yesterday's class, we were studying about the carbon and its. So, we had seen the some important carbon compounds in yesterday's class. That is, we studied about the ethanol in yesterday's class. Like we had studied about the properties and the reactions that are going to happen with the ethanol. So, in today's class, we'll be studying about the ethanoic acid. That is the second carbon compound. So what is this ethanoic acid? So ethanoic acid is commonly called as the acetic acid. So that formula is like CH3COOH. So that is the formula for the acetic acid or the ethanoic acid. Then this belongs to the group of acids. That acid is called as carboxylic acid. Then when this ethanol or the ethanoic acid or the acetic acid is mixed with 5 to 8% of water, that 5 to 8% of the solution when this acetic acid is made, so it is called as vinegar. So this vinegar you can use it in the preservation purpose. So it is being used as a preservative in many of the pickles, and in our household we use this vinegar for the various purposes. So this was about the ethanoic acid or the acetic acid. So then what happens is, if you take this ethanoic acid or the acetic acid, so what happens is the melting point of this pure ethanoic acid is about 290 Kelvin. So this, by this you can say that the ethanoic acid, it freezes during winter very often in cold climates. So by this it freezes very easily due to the cold climate. So it is given another name, that is the glacial acetic acid. So it is called as glacial acetic acid. Then the ethanoic acids, they are the group of the organic compounds which are called, or they belong to the group of the organic compounds. Those are called as carboxylic acids. Then how these carboxylic acids are being characterized is, they are being characterized by their acidic nature. So you can see this whether it is an ethanoic acid or the carboxylic acid. So these have been characterized, or their nature is usually acidic in nature. Then unlike the minerals like HCl, which are completely ionized carboxylic acids, so when you compare the HCl or the H2SO4, so these carboxylic acids, they will be very weaker in nature. So when compared to the HCl, which are the strong acids, so these are very weaker when you compare them. So this was about the properties of the ethanoic acid. That is, it is commonly called as acetic acid. Then its melting point is 290 Kelvin. So by this it says that it freezes very easily during the cold season or cold climatic conditions. So by this it is called as glacial acetic acid. So this 5 to 8% solution of acetic acid is also called as vinegar, which is being used as a preservative in many food items. One such is the pickle. So this was the properties of the ethanoic acid or the acetic acid. So now we'll see what are the reactions that are going to happen with the ethanoic acid. So there are three reactions, that is the reaction of ethanoic acid, that is esterification reaction, then reaction with the base, then reaction with carbonates and hydrogen carbonates. So now we'll see the reactions. Reactions with acetic acid. So first reaction here is the esterification reaction. So you can see what is this esterification reaction, or the formation of ester. There is a figure given, that is in your textbook, that is figure 4.11. So in that they have kept the in test tube, they have kept the mixture that is going to convert the mixture into only ester as a product, and they have stand the burner, they have tripod stand there and then they have wire cage and a beaker. In that beaker they have kept the water, and that process takes place, or the reaction is going to take place. So what is that? Is like esters are most commonly formed by the reaction of an acid and an alcohol. So whenever the esters, they are formed when they react with either with ethanol or alcohol and the acid. So there is a formation of the ester. So what happens is the ethanoic acid that reacts with the absolute alcohol in the presence of an acid as a catalyst. So in yesterday's class we had seen what is this catalyst. So catalysts are those substances which help in the proceeding or the occur of the reaction without affecting the further process of the reaction. So we have seen yesterday that in ethanol, the reactions which are going to happen. So what are these catalysts and what are they useful? So this formation of ester, that is also taking place in the presence of an acid that acts as a catalyst. So this acid acts as a catalyst. So what they have taken an acid. The example could be ethanoic acid. Then they have taken an ethanol, that is an alcohol group. So they have taken these two. Then with the help of an acid as a catalyst, they have formed the ester. So that reaction we will write it on the board. So what they have taken the ethanoic acid, that is CH3, COOH, plus this is the acid. Then they have taken ethanol, that is CH3, CH2, OH. So it is a reverse process. So with the help of an acid, so that acts as a catalyst. So that is being converted into ester. So ester is So this is the esterification. So this process is called an esterification process. So what they have taken? They have taken this ethanoic acid. Then they have taken alcohol, that is ethanol. Then they have formed an ester. This is the final product. So this is how the esterification reaction takes place with the liberation of water. So this is the esterification reaction. So this reaction is called as esterification reaction. So I hope this is clear for you all, that is esters, how these ester is being formed. So esters are most commonly formed when they react with acid, alcohol, then with the acid that acid acts as a catalyst. So they form this ester. So this was about the esterification reaction, and the first reaction, that is reaction of the acetic acid or the ethanoic acid. So next one is like you can see that these esters, they have usually sweet smelling substances. So these, when you check the smell of these esters, the smell would be similar to that of the sweets. Some of the sweets, how they smell, they have the same property as the sweets substances or sweet items have the smell. So what they use is, by this the esters are being used in many of the perfumes or any of the scents, and even the flavoring agents. So in many of the flavoring agents, these esters are being used. So you can see that these esters, when you try to react them with the sodium hydroxide, so that is the alkali nature, that is NaOH, then you can see that again we get the salt of the carboxylic acid, then it is back converted to alcohol and the salt of the carboxylic acid. So you can see that reaction. So this reaction is called as saponification, because it is used in the preparation of soap. So these reactions are usually used in the preparation of the soaps. Soaps are usually the salts, or they contain the sodium and the potassium salts of long chain carboxylic acid. So these soaps, whatever they are prepared by this process, they contain the sodium and potassium salts of the carboxylic acid. So what happens is, you can see here, that is when this CH3CO that is being reacted with NaOH, that is sodium hydroxide, which is an alkali in nature, then back to we get the alcohol and the then we get the sodium salt of the carboxylic acid. So this is an alcohol and this is the sodium salt of carboxylic acid. When they are reacted, this is being reacted. So this process is called as saponification. So don't get confused with what is this esterification reaction and what is this saponification reaction. So when you take acid and alcohol, then you get this ester. So when this again ester is being reacted with the alkali, that is the sodium hydroxide, then we get again back an alcohol and sodium salt of carboxylic acid. So these are being used in the process of soaps, since they get the salts of the sodium or potassium salts of the carboxylic acid. So they are being used in the preparation of soaps. So this process is called as saponification. So this is called as saponification. Then this was the second reaction. So this was the second, then we have seen esterification. The next one is the reaction with the bases. So generally, like minerals, like some of like minerals like ethanoic acid, they react with the base such as sodium hydroxide to give some of the salts. So what happens is, some of the mineral acids, like if you take ethanoic acid, they react with the base such as sodium hydroxide to give the salt. So that salt is the sodium ethanoate, or commonly called as sodium acetate. So this is being formed during the reaction of the base. So ethanoic acid can also react with base. Then there is a formation of sodium salt, that is sodium ethanoate or sodium acetate, and the water is being formed. So that reaction will be seen. That is the second reaction, that is reaction with the base. So what happens is, when sodium hydroxide reacts with CH3, CH3COH, then CH3, so this is the sodium acetate or sodium ethanoate. This is called as sodium acetate or sodium ethanoate. So when sodium hydroxides are being reacted with any of the acids, like ethanoic acid, for example, they have taken ethanoic acids. So there is a formation of sodium salt, that is sodium ethanoate or sodium acetate, and water is being formed. So this was the second reaction. Then have you ever thought like how these carbonates and hydrogen carbonates are being reacted with the ethanoic acids? So that reaction will be this reaction with the carbonates and the hydrogen carbonates. So we'll see how these reactions are going to happen. That is the reaction with the carbonates and the hydrogen carbonates. So that will be the third reaction. Third one, reaction with the carbonates and hydrogen carbonates. So now we'll see how this ethanoic acid reacts ethanoic acids, usually they react with the hydrogen. Ethanoic acids, they usually react with the carbonates and hydrogen carbonates to give the sodium acetate. So they give the to give rise to a salt, carbon dioxide and water. The salt which is formed is the sodium acetate. So again there is a formation of carbon dioxide and the water. Carbon dioxide is being liberated. So both the salt which is produced, that is called as, here also we get sodium acetate, that is CH3COONH. So in last reaction, that is reaction with bases, there is also formation of the sodium acetate or the sodium ethanoate, and reaction of carbonates and hydrogen carbonates also gives the salt of the sodium, that is the sodium ethanoate or the sodium acetate. So now let's see how these carbonates or the hydrogen carbonates are going to react with the ethanoic acid, that is CH3COOH, that is Na2 sodium carbonate. Then we get this was the help of carbonates, this was the carbonate. Then the same ethanoic acid that is being liberated with the hydrogen carbonate, that is sodium hydrogen carbonate. Then also there is a formation of sodium acetate. So this was the formation in both the cases. You can see that there is a formation of sodium acetate. So this was the reaction with the sodium, that is hydrogen carbonates and the carbonates with the ethanoic acid. So this was about the properties of ethanoic acid and the reactions that are going to happen with the ethanoic acids. The next one is the soaps and the detergent. So why we use these soaps and detergents, that we are going to study. What is the soaps? You can see that the soaps are usually the long chain carbon chains of salts of sodium and potassium. So most of the dirt which is oily in nature, and you know that oil will never dissolve in water. So whenever we try to dissolve that in water, this oil will not get dissolved. So it is oily in nature. Most of the dirts which are oily in nature. So the sodium, that is the soaps, they usually contain the salts of potassium and sodium. So this helps in the cleaning agents. So that is being used as a cleaning agent, such that we get the clothes being cleaned by the help of the soaps and the detergents. So these soaps, what they contain is the sodium and the potassium salts of the carboxylic acids. So you can see what happens is whenever you can see that in your textbook that is given in figure 4.12, that is the formation of measles, that is the oil drop. So whenever you drop this, whenever you see this drop on your cloth, then you go for cleaning. So that soap contains the salts of sodium and potassium of the carboxylic acid. So what happens is there is a formation of the measles. So what happens that the soap molecules, what happens is the ionic end of the soap, so one end of the soap, that is the ionic end that contains the Na+, then that interacts with the water. So that goes on interacting with the water when we clean the cloth, and while the carbon chain interacts with the oil. So since these soaps, they contain the long carbon chain, what happens is if you take that one end of this chain is the ion which is present, that is if you take an Na, so that reacts with the water, and and the long chain carbon chain that reacts with the oil droplet, then it goes towards the oil droplet. So if this is the oil droplet, you can see that whatever is the one end that reacts with water. So this enables ions reacts with water, and the other end long chain carbon reacts with oil, and that gets clean. So this formation is called as a mesocyl. So this forms the emulsion in water. So these regarding the emulsions you will be studying in your higher classes. So this is called as emulsion. So this soap thus helps in the cleaning of the or this soap measles helps in pulling out the dirt from the water, and we wash our clothes clean. So with the help of these reactions which are going in water and soap with cloth, so this reaction happens. I hope this is clear. That is the formation of mesocyl. So imagine if there is a oil drop. So what happens is whenever we try to wash this oil drop, so this soap comes in contact. So that soap one end has the ion, that is the sodium ion, that reacts with water, and the other end it goes on reacting, that is the long chain carbon chain that goes on reacting with the oil drop, and there is a formation of mesocyl. So thus there is an emulsion which is taking place in water. So with the help of this, the dirt is getting cleared and we wash our clothes clean. So this was about the soaps. So there is a formation or effect of soap getting cleaned in your textbook that is given in figure. So that about the mesocyls. So what happens is one end of this is the hydrophobic and one end is the hydrophobic and hydrophilic. So these two that gets react, then the cloth gets clean and the dirt goes out. So just read once that soaps are the molecules in which two ends they have different properties. So the soap molecules which are present in water or the soap has two different properties. One is the hydrophilic and the other one is the hydrophobic. So due to their nature, this helps in the cleaning of the cloth clean. So that interacts with the water. So one end is the hydrophilic. So which is hydrophilic that interacts with the water. So for example, this sodium which is hydrophilic in nature that reacts with water, and the other end which is hydrophobic that reacts with the hydrocarbons. So this reacts, this is the other end which reacts with the hydrocarbon, that is the hydrocarbon reacts with this water. Then when soap is at the surface of the water, the hydrophobic, that is the tail of the soap, will not be soluble in water, and soap will lie along with the surface with ionic ended water and hydrocarbon train protruding outside of the water. So you can see hydrocarbon chain will be outside the water molecule, and the other, so by other end will be in water. So hydrophobic and hydrophilic. So due to this nature, that is the soap has two ends. Those two ends have different properties. So because of this, it is being getting clean. Then this was about the soap. So just go through that figure or do more about to know. You will be clear about this problem. So then, how have you ever observed that while taking or while you bathing, you can see that somehow there won't be any formation of the lather very easily. So what you do, you go on applying more amount of soap over it. So after some time, there will be a lather formation. So why does this happen? So this happens like there is a presence of some insoluble substance that remains after washing with the water. So that remains in water. So this water which we are using may be having the hard water which is insoluble. So that substance remains on our hand, so that even after washing with our water, it doesn't go. So that becomes whitish in color. So that is called that substance. So this is called this is caused due to the reaction of soap with the calcium and the magnesium salt with the calcium and magnesium salts, which cause the hardness of the water. So this is because of the hardness of the water. So because of hardness, it is insoluble. So these salts remain, which are present in soap, that remains in water. So this causes white color in nature. So this problem can be overcome by using the detergents. So what happens in case of detergents? So these are the other class of compounds which are being used as a cleansing agent. So these detergents, they usually have the sodium salts of sulfonic acid or the ammonium salts with the chlorides or the bromides. So these detergents, they usually have the sodium salts of sulfonic acid or the ammonium salts with the chlorides and bromides. Because of these both have the long hydrogen chain. So the ends of these compounds, they do not form any precipitate, insoluble precipitate. So you can see that they act as the cleansing agent. So with the help of these calcium and magnesium ions, which are present in hard water, so when they react, then they remain very effective in the hard water. So these ammonium salts or the sulfonic acids, which are sodium salt of sulfonic acid or ammonium salts, the chlorides that are present in detergents, then these salts, when they react with either potassium or calcium, magnesium or calcium, which is present in hard water, then you can see that the reaction takes place and they remain very active in the hard water. So these salts remain very active. Then detergents are by these reactions, we can say that these detergents are being used as a cleansing agent. So usually these detergents are being used in many of the products, one such as you can see in shampoos or the powders which are being used for the cleaning of the clothes. So these detergents are being used in recent days. So this was about the detergent. So I hope it is clear for you all about the soaps and detergents. So it is very simple. About this, you will be studying in your higher classes. Just go through this soaps and detergents once again. So if you have any doubts, please let me know so that I will repeat it for you all. So this about this carbon and its compounds, we have completed that chapter. So there we have seen about the carbon and how what are the compounds like alkenes, alkynes, and alkanes, and alkynes. Then we have seen how the carbon also, other than carbon, also forms bonds with the other atoms like halogens, oxygens, nitrogen. Then we have seen homologous series. Then how these naming of the organic compounds have been done. That is, the nomenclature is being done for the organic compounds that we have seen. Then we have seen chemical properties of the carbon compounds, that is combustion. Then oxidation, where we have seen addition reaction and substitution reaction. Then we have seen some of the important carbon compounds, that is ethanol and the ethanol and the ethanoic acid, their properties, and how they are going to react with those acids, bases like sodium and carbonates and hydrogen carbonates. So lastly, we have seen about the soaps and detergents. So hydrophilic and hydrophobic. So with those two terminologies, you need to be very clear so that it makes you understand very easily in your higher classes. So this was about the chapter carbon and its compounds. So in next class, we will be seeing about the further chapters. So in next class, we will be seeing. So if you have any doubts, please let me know so that I will repeat it once again for you. So I'll wind up for today's class. So thank you. Have a nice day.